Okay, hello class. This is the video uh, going over some of the examples that I promised last week. In fact, there are two examples that is in your notes, but I added two more because I wanted to show you how to do some of the homework problems. Okay, so first we want to look at the homework problem number 5 in section 4.3. It says that the product of two numbers is 2,527 and their GCD is 19. Find their what the least common multiple. Okay, now the way we will solve this is what we want to use. Okay, one of the theorems that we established from class last week. If you remember that, if you have the two numbers A and B, okay, the two numbers A and B, all right? And then if you find the greatest common divisor of A and B, and you multiply it by the least common multiple of A and B, is equal to the product of the numbers A and B. In fact, this is the theorem, okay? The theorem 419 on page 220. Okay. So in this question, we want to let the numbers, okay, let the numbers be what? The A and B. Okay, according to I said the A and B, the product, that means that AB is equal to the 2,527. Okay, 527. And we have the what the greatest, the common divisor of A and B is also giving us what 19. So substitute this into this formula here. Okay. And that will give you the 19 times the least common multiple of the numbers A comma B is equal to their product, which is 2,527. And so we're going to divide both sides by what? By 19. And this side's also by 19. Okay. And you can have what? The LCM of the numbers A and B is equal to the 2,527 divided by 19. That gives you 133. Okay. Therefore, the LCM, okay, the LCM of the numbers is what? 133. And that is your answer. Okay. The second example is an application on page 5 of the notes, 4.3 notes. The jazz has 42 yards of red ribbon and 42 yards of blue ribbon. What's the largest possible pieces of ribbon jazz can cut so that each piece is the same length and all the ribbon is used? Okay, so all the ribbon is used. Now, we want to solve this, we got to look at certain things. First, so that's a solution. First, we have what? 72 yards, okay, of red what ribbon. And then we have 42 yards of what? Blue ribbon. Okay. Now, what does it mean? Since we have what? This is a keyword. Since we want the largest possible pieces of our ribbon. Okay. So that means that we want the largest, and the number of pieces should be number that divides both was 72 and then 42. Okay. And so that means that we need to find, okay, we want what? We want to find a number, okay, that divides what? Both 72 and what? 42. And that number is also what? The largest. It is what? Also the largest number. Okay. But that largest number possible. So what does it tell us? Okay, that tells us that we want the what? The greatest common divisor between what? 72 of the number 72 and 42. Okay, so we're going to use the prime factorization method. Okay, the prime factorization. Okay, to find this. So 72, there was a prime factorization of 72 is what? 8 times 9, right? But none of them is what? Is prime. So 8 to the prime, put in the prime numbers would be 2 to the third power times 9 is what? 3 squared. All right. So that is the prime factorization of 72. What about 42? Okay, 42 is 6 times what? 6 times 7. Okay, 6 is not prime, 7 is prime. So that would be 2 times or 3 times 7. Okay, so what is the greatest common divisor between of the numbers 42 or 72 and 42? It's going to be, if we have to pay the common prime factors there. So in this case, will be what? 2 times what? 3. And then for the exponents, we pick the what? The least. Okay, we pick the least. So for the prime number 2, the least is 1. All right. And the prime number 3, the least is 1. So this would be what? This would be 6. So what does it mean? The largest pieces of ribbon that can be cut is what? Okay. It means the largest pieces of ribbon, okay, that can be cut is be what? It will be what? 6 what? 6 yards. Okay. And cut it into 6 yards so that all of them have the same length and all the ribbon is used. Okay. So that's how we got a 6. All right. So in this case, we found the what? The greatest common divisor between of the numbers 42 and then 72. All right. Now, the third, it's the homework question number 8, which is also on page 5 of the notes. Okay. It's a movie renter store gave a free popcorn to every 15th customer and free movie rental for every 40th customer. What customer was the first, take note of that, was the first to win both prizes? Okay, so what does it mean? You have, okay, the solution, free what? We have a free popcorn, okay, for every what? Every 15th customer. Okay, what does this mean? Okay, these are, so we have for the every 15 customers. So the first person to receive a free popcorn will be the 15 customer, the 30, the 45, the 60th customer, and so on. So you can see that you have for 15, okay, you have 15, you got to a 30, you got to a 45, you got 60. Now, what are these? These are multiples. These are multiples of what? Of 15. Now, similarly, we're giving free word movie. So rent a movie, okay, free movie, all right, for every 40th customer. Now, as you can see, this will be what? The first to receive a free movie will be the 40th customer, the 80th, the 120th, and so on. So again, what is this? This is what? This is these are multiples of what? 40. Okay. And the customer that will receive both of them will be when we keep listing the 15, the counts of 15 and the counts of 40, where they coincide, like we showed you in the number line. What is that? That is basically the least common multiple of the two numbers, 15 and then 40. Okay, so basically what we use that, this means we want the least common multiple of the numbers 15 and then 40. Okay, now if you use the prime factorization, okay, again, I'll just show you. Next time I won't need to do that because we've done a lot of examples. So 40 is what? The 8 times 5, which is 2 to the third times 5. And then the 15 is basically 3 times what? Times 5. All right. So the least common multiple of this will be it doesn't have to be the common prime factors. It's all the prime factors. So it'll be 2 times 3 times 5. And then the exponents will be the prime factor with the greatest, for each prime factor, one with the greatest what? Exponent. Okay, for the prime factor 2, we have what? We have 3. The prime factor 3, we have what? That's raised to 1. And the 5 is also 1. And so basically you have what? 8 times 15, which is going to be what? 100 and what? 120. So that means that the 120th customer, okay, receives both what? Both prices. Okay. So 120th what? Customer will receive what? Both prices. Now, if you keep going like this, you're going to have 120 and then 240 and that kind of. But the first question says that with the customer who first received both what? Prices. And that's why the answer is what? 120 in this case. Okay. And then finally, homework 4.3, question number 7. It says that if there were to be 4 boys and 5 girls at a party, and the host wanted each to be given exactly the same number of candies that could be bought in packages containing 21 candies, what is the fewest? See, was the fewest, all right, number of packages that can be what? That can be bought. Okay, now remember, each package would contain how many candies? 21. Okay, and they have 9 boys and then what? 5 girls. All right, so our goal here, okay, the goal is is to give the same number of what? Candies to each child. Okay, the goal is to give, okay, same number of what? Candies to each what? Each child. Okay, the same number of candies to each child. Okay, now first we need to know how many children were there. All right, so we have to add what? 9 plus 5 equals what? 14. There were 14 children. There were 14 children. Okay, at the what? At the party. There were 14 children at the party. Okay, so now if you have 14 children at a party, what does it mean? That means the total number of, because of our goal, the total number of what do you call it? The total number of candies must be a multiple of what? The number of children at the party and a multiple of what? The number of candies in each package. Okay. All right. So what it means that it means, okay, the total, okay, the total number of what? Candies must be a multiple of the total number of children there and a multiple of the total um, total number of candies in each package. Total number of candies in each package. Okay, so that means that if you want to find the total number of what? There's a multiple. Basically, we are looking for what? The LCM of what? The number of total number of children, which is 14. And then candies, you have what? 20 in each package, 21, sorry. So what is LCM of what? Of 14 and then 21. And this is equal to what? 2 times 3 times 7. And that gives me 40 what? 42. That's 6 times 7, which is 42. Okay, so then to find, according to question, what's the fewest number of packages that can be bought? Say that the fewest, okay, the fewest number of packages okay, that can be bought is going to be this number, the least common, divided by how many packages, how many candies in the package. So that would be 42 divided by what? 21, and that gives us what? Just be 2. So in this case, the fewest number of packages will be what? Just 2 packages in this case. Okay, and that is your what? That is your answer. I hope this is helpful, and that is the end of the example. I will see you Thursday. Thank you. Bye.